So hello everyone, we're very happy to be here. My name is Pascal, I'm from the Architecture and Engineering Office Penzel Valier. We're based here in Zurich. My colleague Martino from the ETH spin-off vyzn. And we would like to talk a bit about data-driven architecture. And we have a first part in the presentation where we go or take a kind of a deep dive into the more or less practical approach. And then Martino is kind of going more into the possible planning process of that. And to have kind of a demonstrator, we try to cherry pick some of the projects and what kind of approaches and aspects we took for very holistic planning. And the aim of this holistic and integral planning was especially to reduce emissions, to reduce energy consumption of different buildings. And we try to kind of focus a bit on the building skin, just to not be too broad, but still have some kind of details. So for the first demonstrator, let's say, we jump into the project for the Swiss National Television. And there we have a new campus, which is already built. It's in Leutschenbach, that's close to Zurich. And there we had the challenge that we have a quite big cantilever of the building. And we created this kind of suspended facade or suspended structure, which then also can take off the use of forces, which is much more optimized in the, let's say, tension way with the steel structure. And therefore we could, on one hand, build the building with less material, but on the other hand, we could also create flexible spaces on the inside, which are without any columns or structures, which was needed for the television part. But also, if you take a closer look for the building, we have quite challenging heat management, let's say. So they have very high internal loads of heat. And therefore, we had to adjust the facade so that we can use the facade as a cooling element. So the building is less insulated than usually in Switzerland, just because we have so many internal loads. Another example or demonstrator would be the new building for the Swiss National Fund, which will be placed in or located in Bern. There we had the challenge that we have to have very flexible office spaces. So therefore we took the structure on the outside. So we created this external, let's say, exoskeleton, but it's kind of an external structure for very flexible inner office layout. And with this external structure, it was also possible to add another element, which is a brise-soleil, which kind of also on one hand reflects light on the inside, and on the other hand it's a kind of a heat management system, a passive architecture element for heat reduction. A third example, just to kind of cherry pick some of the examples in our practice, is the Campus Horb, which is located in Lucerne. And will be built in the next few years. Right now it's in the planning phase. There we go more on the top, and we have this atrium, and on top we have this structure where we use the carbon pre-stress concrete. And with an algorithm it was possible to find most optimized solution in terms of, on one hand, the structure for minimal concrete usage, but on the other hand, it was also possible to use the structure as a light guiding element. So we had, let's say, different influences for this structure, and additionally, we kind of loaded the structure with these solar tracking mirrors, which are then also guiding light into the atrium. So, and there we have kind of very specific, bespoke designing principles for those buildings. And the challenge is really to have different stakeholders on those buildings, different planners, and to bring them together, working on one single part of the building or one single member or whatever. And therefore we kind of try to create new processes. So on one hand, we automated a lot of planning processes so that we can just make quicker iterations. And on the other hand, we have also to speed up in the way we design and bring those functions together. And we also need to kind of have more informed design decisions, and that's kind of where we need to go. We need to be able to have all those informations drawn together and find out the optimized solution for that specific problem, because what we found out through the different projects is really it's really about the project. So if you want to optimize, you cannot generally optimize things because they're very kind of tailored and bespoke. So, and I think that's also where Martino can give you more kind of deep dive information into certain processes to bring those stakeholders together. So, Martino.
Thank you very much, Pascal. As you just mentioned, it's very clear how complex construction are becoming. It's very hard to keep all stakeholders in the same place, make them work together, understand all the different aspects that are needed to be analyzed and understood in order to be able to really optimize buildings. So the question we asked ourselves is, how can we make that possible? So if we want to really automatically optimize construction projects, we need a way to be able to simulate, to analyze thousands of times over the whole lifetime, over the whole planning phases. And why isn't that happening today? And we believe there's two main blockers, one being the low quality of 3D models, the heterogeneity of the models. It's very hard to find two models that are exactly the same under the same standard. And this, looking forward, won't allow AI-powered optimization to really use all the technologies that we have today. The second one is the lack of a single platform where all stakeholders can really work together and have access to tons of different analysis. And now looking at the first of those two problems, what we see is most of the projects today are planned in 3D. Those 3D models are completely different. Most of them don't reach even the minimum level of quality needed for analysis. So there's inconsistent types, missing names, wrong assignments, missing rooms. We have seen a lot. So what's happening today is that gap in order to be able to access analysis, CO2 energy analysis, is covered by consulting. The biggest issue is how long it takes to cover the gap. So to simulate, it could take even longer than 3 weeks, and this generates lots of costs. And the problem is that process, those analyses happen once, maybe twice in the whole planning phase, due to the price and the time it takes. With Vision, the first step is to fix that issue and make it very fast. As of today, thanks to our reference model, we're able to analyze IFC models, 3D models, and make them into one very good standard that can be used for different analysis. So in a matter of minutes, without consulting hours, we're generating tons of data that can then be used in a later stage once we are on the platform to access hundreds of different analyses, to simulate buildings very quickly. You won't have issues with every new iteration your model have. Every small change, you'll be quickly on the platform again and able to improve it. You'll get access to the needed certification, and most importantly, that standardization happening before will give you access to something that was never seen before in the construction industry, meaning an AI-driven, AI-powered optimization. Those analyses I was just talking about, we divided them into 5 big groups. So there's many apps under those bundles, as we can see, starting from emissions, LCA, circularity, going towards cost, comfort, energy performance, power generation, as well as security. Because it's very hard, like I was mentioning before with Pascal, to get all stakeholders in the same place and consider all those aspects. Because even the smallest change on the selection of materials have a huge impact on all those topics. So it's important that we're able to consider them all together. And at the end, exactly what we are trying to solve is to build a place where it's very easy to access, with all your models, where all stakeholders can access to add information, get results, understand the building, and through fast processes, optimize buildings in the planning phase and considering the whole life cycle, having access to all that data that is being generated and lost today, stored in one place, giving you options on how you could build better, build more sustainable, optimize basically what we're building. With the main final goal of reaching a situation where every construction project is automatically optimized to really reach the sustainable potential, but most importantly, without compromising on comfort or on the financial aspects of it, of profitability. So yeah, that was our short presentation on data-driven architecture and what's going to be possible what's possible today and what's gonna wait us in the future. Thank you very much.
Thank you.